Hello and welcome to my very new channel and to my very first video in which I'll be doing project or creating a neural network on the handwritten digit recognition model using Keras. So let's begin. So before coming to the coding part, there are some requirements for this project. That is, you should have installed pre-installed Keras, TensorFlow, NumPy, and the Pillow library for Python, and I'll be using Visual Studio Code Editor for this program, for this, or you can say project, but you can prefer any other editor if you want to do so. So I'll create a folder MNIST digit recognition so that I can share all the codes later on. So I have created a folder. Now I'll be creating a file named train digit recognition, in which the basic code, or you can say the main source code of the neural network, will be done, so that I can use this file to create a model and save it so that I can use it later whenever I require, without that again and again training that model. So very first step is import all the required libraries, so and also load the dataset. So first thing is import Keras, because that's the main library we needed for neural networks. Second is our model will be sequential, so from keras.models import sequential. After that we need some layers like hidden layers, convolutional layers, and pooling layers. So for that we will be importing from keras.layers import dense, dropout, flatten, con 2d, max pooling 2d. We'll discuss later what does a particular layer does in the neural network. And after importing all the things, we will import the backend of Keras as key, but that's not the main thing. The main part is the dataset. So the dataset which we are going to use is MNIST, which is pre-provided as with Keras. So we can import it using keras.datasets import MNIST. Now we will load the dataset, but as the dataset is already divided into two sets, so we will store them as two different sets, test set and train set. So there will be two tuples, xtrain, ytrain, and xtest, ytest, and we will load that data using mnist dot load data. As you can see, now just checking that we have done everything right, we will be creating a checkpoint and just print the shape of xtrain and ytrain. As you can see, when I run this program, it downloads the dataset first. Xtrain and ytrain, capital X, capital Y, sorry. So data is already downloaded, so it will not download it again. As you can see, we have 60,000 images, okay, and the dimensions was 28, but we will create a 3D image, so we'll create it as 3D, or you can say provide it a like it is a grayscale image. So now second steps comes is pre-processing of data, in which we will actually first convert our dataset from change our dimensions of our trained dataset, and then we will do something like label encoding or one-hot encoding, but let's see. I can just everything will be same, but just replace xtrain with the xtest. Xtest.shape0 will provide the number of images, as you had seen earlier in the output, 60,000, and then 28 was the actual size, and then one will be just to increase one dimension. Now just in case we will need the input shape later, so just store the input shape as a tuple 28, 28 and 1. Now let's print y train. So as you can see, y train is in a format of vector, or you can say list, but that was not a list, that was a vector. So we need to perform encoding or that in vector. So I am going with one hot encoding so that I can convert vectors into binary class matrices, and that is actually a best choice for classification problem. So we have a function called toCategorical, which will do all the stuff and will give us an binary class matrix as an output. So keras dot util dot toCategoricals, again the original vectors name, comma num classes. Num classes will be how many classes are there, because it is digit recognition, so I guess 0 to 9, so 10. Same with the test detager, everything will be same, so I will just copy paste it. Again, now we have to perform normalization, or you can say standardization, on the training dataset, as we have too much data here. So firstly we will convert it into float 32 from int values, as pixel values are mostly in integers. So that is by using .as type, which is a function provided in NumPy, and then we will divide it by 255, that is the total value. So again running, we have an error that has no attribute util. Oh, that will be utils. Now everything should be fine. Yeah, so as you can see, there is a difference between extend shape. Above it was 2028, now it is 2828 comma 1. So now coming to the third step, the very most important step of this neural network program or project, is creating the model itself. So as you can see, the model consists basically the input layer, convolutional pooling, then hidden layer, and then output layer, which is for the classification purpose. So I'll create the same model here. So firstly our model is in sequential, so just initialize it. Now coming to input layer. Now input layer will be like, we are passing our images data to convolutional layer, so we will be using convolutional 2D, and the kernel size will be 3 into 3, which will be used for convolution which will act as convolution vector matrix, and activation function will be ReLU, and ReLU is just an function which just takes only positive values, actually it discards all the negative, and then add one more convolution 2D matrix, but with increased number of filters, that is 64. Previously it was 32, and activation function will be again same ReLU. Now we will add the pooling layer, which that is max pooling 2D. So we will keep the pool size 2 by 2, which should be actually less than kernel size. Now coming to the dropout layer. Dropout layer acts as, it is used in order to just reduce the overfitting of data while training, which means it just stops some layers so that it doesn't get so that our model doesn't overfits. Now adding flatten, and then as we have done our first part, now coming to the classification part. So we will need some hidden layers, so I will just create one model dot add dense 256. Activation will be same the ReLU, and then again drop out in order to reduce overfitting. Now coming to the output layer, as there will be 10 outputs, so it will be again num classes equals to 10. For output purpose, we will, and in order to reduce the error, we will use the softmax as our activation function. Now actually I forgot to initialize the num classes. Now just compile the model, and for the loss calculation we will use the cross entropy, and our optimizer will be at a delta. I'll provide the link in the description so that you can read about those, and matrix will be the accuracy matrix, same as the sklearn accuracy score. Now coming to the step 4, which is training the model. Now for the training the model, as you have implemented normal decision tree classifiers, for training any model we use .fit function. We will pass the training and training features and training labels. Now we will I will be taking batch size as 128 and only 10 epochs. So 10 epochs, and we can leave that. And validation, for the testing purpose we have the X test and Y test. Now we will just create another checkpoint, that so in order to check that our program is correct till now, so we'll just create a message after the training, that training successful. And in order to save our model so that we don't have to train our model again and again whenever we need to use this, so we will just save it. So model.save, and the extension will be .h5. So step 4 is done. Now comes the again a message that model saved. Now coming to the last step, that is step 5, which will be the evaluation of our model. So accuracy score equals to model dot evaluate. Evaluate actually does the evaluation part, and we will pass the test sets, and now we will just print our test loss and the test accuracy, which will be stored in the accuracy score will act like a tuple, so it will have two values. One will be the loss while testing, and another will be the accuracy of test data set. So that is how much correct and how much wrong outputs our model had produced on the test data set. Now we can say model creation is done. We can just try and run it. ZD data, desktop, MNIST, digit recognition, Python 3, train, digit recognition. Now as it will take a lot of time, so I'll just skip that. I'll just pause this video, and as you can see we are almost on 10 epochs. So model saved. As we can see our accuracy is almost 100%, that is 99.23%, and we have a new file. So our model name.h5 will be already saved. Now coming to the GUI part, I am assuming that you are familiar with Tkinter, or maybe you are not, so I'll be not explaining this part of that how to create an GUI for this program, so I'll be just fast forwarding it. But the source code will be provided in the description as a link to my GitHub repository. You can always check it there, or if you want I can just make another video on the how to implement Tkinter or how to create an GUI. So just let's skip this coding part of GUI that I have created. So running, and this is the GUI. That's how you have to create something, and whenever you click on done it will show you some output, and I think that's it from my side. I'll share the code in the link in the description. Thank you for watching. Please like, share and subscribe.